Hey, what's up, YouTube fans? So the topic for this video, right, is the evolutionary reducibility of the human integumentary system, right? So showing that the human integumentary system can be broken down into evolutionary steps that did not have to all come about at once in a single step, right? Counter to the argument of irreducible complexity, right? So, first off, the human integumentary system is overall mostly the same as that of our closest living relatives, which are the chimpanzees and bonobos, which cannot be said of most animals, right? Um, but one significant difference of the human integumentary system, right, is that we have shorter hair around most of our body than chimpanzees and bonobos do, more so than any other primate does, right? But we actually have about the same number of hair follicles as chimpanzees and bonobos, right? Roughly speaking. But the main difference is that most of our hair is shorter and finer, right? And the reason for this evolutionary change in the human lineage, the leading view on it is that it was most likely a thermoregulatory adaptation, helping with walking and running while walking on 2 feet, helping with maintaining thermoregulation when walking and running on 2 feet, right? And then next, because we're part of a group of primates called the catarrhines, right? Our nipples are located on the chest, right? Whereas the other group of anthropoids, the New World monkeys, they tend to have their nipples closer to the armpit area. But in most catarrhines, including humans, the nipples are located on the chest. And then because we are anthropoids, that's why we have only 2 nipples, right? But it didn't have to be that way from the beginning. You know, amongst different groups of mammals, you know, most mammals have nipples, right? Teats, right? But the numbering and positioning vary significantly between different groups of mammals, right? But because we're catarrhine primates, we have only 2 nipples, both located on the chest, right? And then also because we're catarrhine primates, we don't have a grooming claw, which is something found in many other groups of primates like New World monkeys and tarsiers and lemurs. In many of them, we find a grooming claw, it's called, but this is not found in the catarrhines, including humans. So old world monkeys and apes, including humans, we do not have a grooming claw, right? Um, and then next, because we're part of a group of primates called the haplorhines, right? That's why we don't have a rhinarium, right? Which is something found in the in most living mammals, right? Which is where it's a hairless wet spot around the nostrils, right? But haplorhine primates, including humans, do not have this, right? So even though we're mammals, we don't have that. Why? Because we're haplorhine primates. And then next, because we are primates, that's why we have nails, right? Which are different from claws in that they're shorter and flatter and wider, right? So if you look at what your dog has, your dog's claws, if you have a dog, that's very different from the nails that you have, right? But if you look at the fingers and toes of a gorilla, you'll see it's much more like what you have, right? Because like you, they have nails rather than claws, right? So on a gorilla, you'll see flat, round nails, much like yours, right? Whereas it's very different on like a dog, right? But the nails of primates are likely derived from the claws found in most other mammals, even in most other amniotes, in fact. Um, but in the primate lineage, what was claws became changed into nails, right? And then next, so Therians, that's a group we're a part of, and it includes the vast majority of living mammals, all living mammals aside from the platypus and echidna. Early Therians is where the rhinarium was most likely evolved. The Therian ancestors after splitting from the platypus and echidna, unless it may have existed in our last common ancestor with the platypus and echidna, and they may have lost it since then, right? But even though we don't have a rhinarium, our ancestors used to, just as most Therian mammals do, right? But you know, the evolution of the rhinarium, it wasn't fundamental towards the olfactory system working, right? So the rhinarium, it helps with the sense of smell in most mammals, right? But most vertebrates have a fully functional olfactory system, even though they don't have a rhinarium. So this can come as an improvement to an already existing olfactory system, this modification to the integumentary system, right? And Therians are also different from the platypus and echidna in that we have teats, right? Whereas platypus and echidna, they have mammary glands but no teats, but their mammary glands are still fully functional. The babies still drink milk from those mammary glands, right? Which shows that the mammary glands and teats did not have to come about at once in a single evolutionary step, as opposed to the teats being an improvement to already existing mammary glands. And then it is because we are mammals that we have hair and mammary glands and sebaceous glands, right? Whereas we do not find these features in our next closest living relatives, which are the reptiles and birds, right? But they still get on just fine without those features, right? And then mammals and reptiles and birds are all collectively part of a group called the amniotes, and most amniotes have claws, right? So we find claws commonly in birds, reptiles, and mammals. We don't have claws, but only because what was claws became nails in the primate lineage, right? And then also in the case of hooved mammals, what was claws became hooves, right? But that's not our lineage, that's a different lineage. And then vertebrates have a corneal epithelium, right? That's part of our integument, right? And there's some insight given as to how this evolved by certain experiments showing like the effects with mutating various genes or knocking out various genes. It's been shown that certain mutations can actually result in a creature being born with skin where its cornea should be, and even growing hair on that spot, right? And then also vertebrates have 3 layers of skin, right? Whereas most invertebrates have just 1 layer of skin, right? Which shows that it didn't have to be from the beginning having 3 layers of skin as it is in the case of vertebrates, right? And the skin was evolved early in animals, right? It was likely the first organ to ever be evolved, actually. And it comes from a specialization of the ectoderm germ layer, right? So that's the outermost germ layer, right? So the germ layers, those are the primary layers of cell during embryonic development. They're layered on top of each other with the middle, the one in the middle being the endoderm, and then the center one is the mesoderm, the outermost one is the ectoderm, right? And so part of the ectoderm becomes the skin. That's how we get the skin, right? So all right, that's all for now. See you guys.